This week we are talking about energy resources, which is chapter 11 in the textbook. You need to look at all the different resources, know a little bit about each one, and you'll be doing a project next week focusing on just one. But as we start, the chapter talks about energy conversions or energy changes from one form to another, and you may or may not remember, but you studied this in 6th grade. Energy going from one form to another. Chemical, mechanical, electromagnetic, thermal, nuclear, and electrical. You guys remember this from 6th grade? In 8th grade, you take this standardized test for science, which covers 6th, 7th, and 8th grade. This is one of the 6th grade things that we touch on now that you will be tested on. So energy conversions. Chemical energy. What are some examples of chemical energy? So this is the summary of the different types of energy that you probably learned about in 6th grade. Electrical energy, again, is one that's very useful for us, but the problem with electrical energy is we have to find a way to generate it. And as we'll talk about as you go through the chapter, most of the electricity we use is from coal-burning electrical plants. When we burn coal to get electricity, you start with chemical energy in the coal, and you burn it, which gets out the chemical energy and turns it into heat energy. Use that heat energy to boil water and turn it into steam. The steam turns a turbine, which makes mechanical energy, and then you use that turbine to generate electricity. Complicated. So the first question on the worksheet was, what energy conversions occur when a car engine burns gasoline? So what are you going to start with? Which type of energy to start with? Chemical. So we're going to start with chemical energy. So in the car engine, we start with chemical, and then what happens? What does it turn into? What do you do with the gasoline? What happens with the gasoline in an engine? Anybody knows? There's a spark that ignites it, causes an explosion, which causes moving things like the pistons. So the chemical goes to mechanical as the engine moves, and the mechanical is transferred through several different ways to ultimately make the wheels turn. Is there another type of energy that comes from the gasoline besides the moving? What else do we get from burning usually? Yeah, thermal energy. Does your car get hot? Yeah. One of the problems with gasoline engines is there's a tremendous amount of heat that is produced. Are you using that heat to run your car? Generally not. So that's one of the problems with the engines in the traditional engines in cars, is you lose a lot of the energy to do that through that. Okay. And then this is from the book. This is what I just went over. Energy conversion. Burning fuel to create heat to boil water, to turn a turbine to generate electricity. And this is generally how we make electricity in the United States. And depending on where you live, the fuel that is burnt is either coal or oil or natural gas, usually petroleum products of some sort. So electricity seems clean, but it's where did you get the electricity from? And this is from the textbook. So one more thing in our lesson for today, and then we'll move on to you guys working independently. But the three major types of fossil fuels, and how do fossil fuels form? And again, this is cut right out of the textbook. And this is what we're talking about. Something like coal or oil is much more dense in energy than if you were to burn grasses or wood. And you think about this, if you throw grass on the fire, it burns very quickly, but then it's gone. Something like coal or oil or natural gas is much denser for that. Natural gas comes from oil shale, so it's a fossil fuel as well. So this is just showing how coal is formed. You guys know the basics of this. You know, things die, they become buried, they become compressed. This is peat In some places like Ireland, they actually burn the peat moss, and because it's dense enough and kind of partially decomposed, um, which is a fossil fuel, and then that ultimately compresses and turns into sedimentary rock called coal, which we can burn. And so again, the fossil fuels are very readily burned. We can mine them and get them. The problem with it is that we will ultimately we are using it faster than you can mine it. And in some cases, it's very destructive environmentally to mine coal. So the three main types of fossil fuels: oil, coal, and natural gas. And again, the natural gas, you can find pockets of natural gas, but the other way, natural gas is cleaner burning than the other two types of fossil fuels. Um, and for instance, many of us have natural gas, similar to burning like a propane burner or your gas grill. Many of us have natural gas piped into our houses, and that's how we heat. That's what heats our water heaters and runs our furnaces and sometimes our stoves. So natural gas is a clean burning fossil fuel. And the thing that you've probably heard about quite a bit, that's a new enough issue the textbook does not talk about it very much, is something called fracking, which is just kind of a nickname for hydraulic fracturing, which is a way of getting natural gas out of oil shale. And so natural gas is found in the sedimentary rock. It's called shale. And the oil shale, you might remember seeing it when we talked about rock types. It's layered. It sometimes has fossils in it. And sometimes if you actually snap it in half, you can smell that oily smell. So hydraulic fracturing is a process where they put these pipes down. And again, you've probably seen the stuff on the surface. They put pipes down. They put a well down into the ground. And around here, they're very, very deep down. And then from this one central well, what they've been able to do that's making fracking a very useful thing from here, then they do this, they go out sideways. And so from this one well, they can get all of these areas with this horizontal drilling, and they even go down at an angle. And so from one well, they can go to all these areas. And then they pump down water at a very high pressure, and that water fractures the layers of shale, and the gas escapes, and then they pump out the gas. So the good things about fracking are that it's a cheaper, cleaner burning fuel. We seem to have a lot of it here in the western United States. And they've gotten pretty good at getting it out in a relatively non-invasive way. Now, the bad things are it actually uses a tremendous amount of water to do fracking because you're pumping water down there. And as you probably know, here in the western United States, water is not something we have a lot of. And so it's using water to do that. They're working with ways to recapture the water, reuse the water. That's an issue. I don't think the problem with ocean water is it's very salty, and salty water corrodes metal. So in addition to having the actual salt in it, which is a small particulate, which I don't know if it would make a difference, salty water corrodes metal. So then you'd have to desalinate it, which actually takes a lot of energy. So right now, that's unfortunately not an issue. And then if we did ocean water, we'd have to truck it in here somehow. So they're finding ways to recapture the water, recapture the water. The other thing is when they pump the water down, it's not just water. The water has some like detergents and stuff in it. And right now, most of the fracking they do is way below our water table. So the water that people might drink is higher up here. But we just don't have enough information to know. The fracking companies say, of course it's safe. The people who live in the areas say, I don't think it's safe. But I don't think, from what I've been able to find on both sides of the issue, we don't have enough data, especially not long-term data, to know, are there long-term issues with the water table from doing the fracking deep beneath it? And they do a lot of things. They'll put concrete sleeves and stuff to protect and do all that. But because it's a relatively new process, and the other thing is the fracking goes on, as you know, right next to subdivisions. You see the fracking towers right next to huge, subdivisions of houses. So, and I assume that's because then you can truck the supplies in and out and get the gas in and out. So that's a little bit about fracking, and I'm sure one of you will take and do more detail on that. Okay, then you'll work on this part. These questions are simple. You just answer them based on the pie graphs, which is a piece of cake. And then last of all, this part, I just wanted to show this real quickly, because this to me, I don't think very many people realize. But again, this is a picture from the textbook. When you refine petroleum, so you start with oil, and then you have all of these different products that are made from oil. And the most crude and kind of nasty stuff down here is asphalt, which you see put on the roads. You know what that looks like. Asphalt. You've got grease and wax, diesel fuel, heating oil, which again, we don't use that much in this part of the United States, but they use it a lot back east. Jet fuel, gasoline, and then other gases. So the gasoline we put in our car, when you start with a barrel of oil, is refined into all these different processes through heating and separating based on density and boiling point and stuff. So that's just a quick summary of it, of some of the fossil fuel stuff.